Relativistic velocity addition. So far we have dealt with the Lorentz transformations for position and time, but there is also a transformation for velocity, the Lorentz velocity transformation. By the way, if you like this video, don't forget to like and subscribe to this channel and activate the bell. It's very important for the continuity of this channel. Suppose a spaceship heading directly towards the Earth at half the speed of light sends a signal to us on a laser-produced beam of light. Given that the light leaves the spaceship at speed c as observed from the spaceship, if we considered the Galilean transformation applied to light, then the light from the spaceship would approach the Earth at speed v plus c, contrary to Einstein's postulates. In cases like this, where velocities are relativistic, we must consider the Lorentz transformations. We now wish to use the Lorentz transformation equations to compare the velocities that two observers in different inertial reference frames, S and S prime, would measure for the same moving particle. Suppose a particle is moving with a velocity u as measured in frame S. Another inertial frame S prime is moving with a velocity v with respect to frame S. The velocity of the particle as measured in frame S prime is u prime. Suppose that in the time interval delta t, this particle moves a distance delta x as measured in frame S. We can use the Lorentz transformation equations for pairs of events for writing delta x and delta t as follows. If we divide the first of these equations by the second, we find: divide the numerator and denominator of the right side by delta t prime, we find. As we know, delta x over delta t is the velocity. Finally, we get the velocity of the particle as measured in S. To solve for u prime, the primed and unprimed quantities are exchanged, and the velocity v is replaced by minus v. Let's summarize in the figure as follows. Let's see how it works. To solve this question, first select the frames S, S prime, and hence the velocities v, u, and u prime. Usually, the velocities of two objects are measured with respect to frame S. One of the moving objects is frame S prime. The frame S is the ground and S prime is the rocket. We can now simply substitute the values into the Lorentz velocity transformation. Let's see another example. First, select frames S, S prime, and hence the velocities v, u, and u prime. Suppose the frame S is the frame of reference in which the first rocket is at rest. So the frame S prime is the frame of external reference frame that moves to the left with speed minus 0.75 times c. We now draw a picture of the situation. We can now simply substitute the values into the Lorentz velocity transformation. Let's see another question. First, select the frames and velocities. The spaceship B is frame S since the problem requires the velocity of spaceship A with respect to B. The frame S' is the frame of the planet X that moves to the left with speed minus 0.9 times c. We now draw a picture of the situation. We can now simply substitute the values into the Lorentz velocity transformation. The negative answer implies that A is moving away from B. Let's see another question. Select the frames and velocities. Suppose Jean is the observer at rest, so Jean is frame S, since the problem requires the velocity of Philip with respect to Jean. The frame S' is the frame of the Philip. The spacecraft moves to the left with respect to Philip and moves to the right with respect to Jean. We now draw a picture of the situation. Philip is moving relative to Jean with speed v, so we can solve this equation for v. We can now simply substitute the values into the Lorentz velocity transformation.